All right, we're going to get down to business. So if you have a problem, you want to develop a rational approach, you have scientific aspirations, you need some baseline data. And many of you will know that Rebecca Siegel from the American Cancer Society provided the first insights to the epidemic of young adult colorectal cancer. She's been working on this for many years with many seminal publications that have literally transformed how the nation and the world views this problem. We are extremely privileged to have Rebecca with us today, and she's going to update us on the basic metrics and data surrounding young adult colorectal cancer in these United States. Please join me in welcoming Rebecca Siegel.
Good morning. Thank you, Tom, for inviting me back to the summit again this year to share some new results from ACS on 2 studies that are currently under review for publication. So I need my slides. There we go. So I'm going to talk about the results from 2 new ACS studies today, both of which, as I said, are under peer review for publication, and so please no dissemination of the content of these slides because it's currently embargoed. I'll start out with just a couple of background slides. These figures are familiar to many of you. I've updated them with brand new SEER data through 2016, and they show the long-term declines in colorectal cancer incidence rates in adults 50 and older because of the uptake of screening and changing patterns in risk factors like declines in smoking and increased use of anti-inflammatory drugs. While at the same time, there's been an increase in younger adults of now 55% since the mid-90s for reasons that remain unknown. Please note that in these figures and in some of the other figures that I'll share, the y-axis scales are different because the focus is the trends within each age cohort and not the difference in colorectal cancer incidence rates between them. Incidence rates for early onset disease are slightly higher in men than in women, but the trends are strikingly similar. Excuse me. And this enables us to combine men and women in our studies to improve statistical power. A couple of years ago, we reported that the increase is much larger for rectal cancer than for colon cancer, and it's been going on for longer. And there's also a very strong birth cohort effect in the data. Incidence rates have decreased for subsequent generations during the first half of the 20th century, but since around the 1950s, rates have been increasing for every subsequent generation, such that for people born during the 1990s, like my children, the rate of colon cancer is 2 times higher than people born around the 1950s, and the rate of rectal cancer is 4 times higher. This very strong birth cohort effect suggests that it's behavioral exposures driving this trend and not changes in medical practice. So in this first study, we were interested in looking at whether or not there are geographic differences in the pattern to contribute to etiologic hypotheses. We analyzed data from the North American Association for Central Cancer Registries that contains information on 47 states covering 95% of the population during the last decade of data. And we stratified by race and ethnicity because we and some other researchers have shown that the trends differ by race and there's a vast variation between states in the racial makeup. In a secondary analysis, we looked at changes in the prevalence of two established risk factors for colorectal cancer: obesity and heavy alcohol consumption. And although diet and physical activity are also of high interest for the early onset trend, we didn't look at these separately in this study because they're so strongly correlated with obesity. This slide shows the beginning of the results. This is data at the national level for 4 broadly defined racial and ethnic groups. These are trends over the past 2 decades for colon cancer on the top row and rectal cancer on the bottom row. The rate increased among non-Hispanic whites for colon cancer, while decreasing slightly among non-Hispanic blacks and remaining stable among Hispanics and Asian and Pacific Islanders. In contrast, rates for rectal cancer increased in all groups except for Asian and Pacific Islanders, although the magnitude of the increase in non-Hispanic whites was twice that in blacks and Hispanics. Because it's non-Hispanic whites that are driving the trend, I'm going to focus on the results for non-Hispanic whites for this study in the rest of this presentation. So this map shows current incidence rates for early onset disease by state. Rates are highest in the South and range from a low of 8.2 per 100,000 in DC and 8.7 in Alaska to 14.3 in Kentucky. And this is a very similar pattern to what we see for older adults. This map shows changes in early onset incidence by state. So this is the average annual percent change over the past 10 years of data. And the largest change is shown in the darkest color. So and this is specifically non-Hispanic whites. So there was a statistically significant increase in 40 of 47 states. And in the remaining 7 states, the rates were stable. So you can see that the largest increases were in Western states. In many states, the increases for rectal cancer were twice those for colon cancer. And in fact, in some Western states, rates of colon and rectal cancer converged, as happened in Colorado. So in the mid-1990s, rates of colon cancer were about twice those for rectal cancer, whereas in 2015, they were the same. And the reason is because you have this rapid increase in rectal cancer incidence rates in Colorado of over 4% per year, compared to an increase of 1.5% per year for colon cancer. And there was a similarly high increase for rectal cancer, over 4% per year in Nevada and Utah. This slide shows results from the correlation analysis to look at the extent to which there's a linear relationship between changes in obesity prevalence in young adults and changes in early onset colorectal cancer. So the average annual percent change in colorectal cancer incidence over the past 10 years is plotted on the y-axis for each state, compared to the change in obesity prevalence between 1995 and 2005. Despite the fact that there was an increase in obesity in every state, the correlation coefficient was not significant, suggesting no correlation. And the correlation analysis for heavy alcohol consumption was similarly non-significant, although heavy alcohol consumption increased in only about 1/3 of states. Importantly, those results do not mean there's no, that obesity isn't important in the early onset trend, because correlation analyses are ecologic and they're inherently limited by their inability to analyze individual exposure and disease. And I wanted to show this study to bring this home. This was published a couple months ago. This is an observational study based on the Nurses Health Study 2 data. And these investigators reported a 20% excess risk of early onset colorectal cancer for every 5-unit increase in BMI. So there's definitely an association, but the extent to which obesity is influencing the trend still remains unknown. So now I'm going to move on to the second study. It's indisputable that incidence rates for early onset disease are increasing, but sometimes trends for cancer reflect changes in diagnosis instead of changes in cancer occurrence. We saw this in the 1990s for prostate cancer, and again more recently for thyroid cancer. And there are some people who believe that the increase in early onset disease is because of more colonoscopy use in people younger than 50. This has been a difficult question to answer, the extent to which increased colonoscopy contributes to the rise, because there's no published data on population-based colonoscopy use in people younger than 50. But hopefully shortly there will be. The second study, we analyzed changes in the prevalence of past year colonoscopy use among individuals in their 40s based on the National Health Interview Survey, which is an in-person household survey that's the only source for population-based data on colonoscopy use in people younger than 50. And it is limited to people 40 and older, so we couldn't look below age 40. We also looked at the corresponding changes in colorectal cancer incidence rates during the same time period for the same age group. And this slide shows the results of the colonoscopy prevalence data for every survey year between 2000 and 2015. Among the youngest age group, there was no change. The prevalence bounced around 3% during the entire 15-year time period, whereas among 45 to 49 years, the prevalence doubled from about 2.5% to about 5%. Importantly, in interpreting these data, this is colonoscopy for any reason, so not just a screening colonoscopy. It includes diagnostic exams. So if you have an increase in disease, you would expect an increase in colonoscopy. And this slide shows changes in colorectal cancer incidence trends during the same time period for the same two age groups. Incidence rates increased by 1.7% per year in ages 40 to 44 years, and that was a statistically significantly larger increase than that in the 45 to 49 years, which was 1.1% per year. So if you'll recall from the last slide, this is inconsistent with the colonoscopy data because colonoscopy prevalence was flat in the younger age group, yet we have a larger increase. These figures show colorectal cancer incidence rates for the same age groups by stage at diagnosis. And the reason stage is important is because when there's a screening effect, you expect larger increases for localized stage disease. And in fact, the opposite is happening. The larger increases for distant stage disease in both age groups. And in fact, localized stage disease is stable in the older age group. So again, this is inconsistent with the screening theory. And finally, mortality data are inconsistent with the screening theory. A couple of years ago, we reported an uptick in colorectal cancer death rates in young age groups beginning around 2004. I've updated those data with 3 additional years of mortality in this slide, and the increase in death rates is continuing and is larger among whites, consistent with the incidence pattern. So in summary, the data do suggest a true increase in colorectal cancer in young adults that is due to changes in exposure, perhaps in addition to obesity, but that remains uncertain. The steepest increases are in the youngest generations for tumors in the rectum among non-Hispanic whites and in Western states where healthier lifestyles predominate. But importantly, the highest rates do remain in the South. And I wanted to leave you with this. People tell me often that the absolute risk of colorectal cancer remains low in young age groups, and that's absolutely true. But the numbers are not small, nor is the impact on these families. In 2017, there were 3,600 deaths from colorectal cancer in people younger than 50. That's 10 deaths per day among our most productive citizens. I'd like to thank my collaborators on these projects, and thank you for your attention.